Hello, so I will be going over the CS 113 midterm going in each section. So this is section 1. So section 1 was just a simple matching. Again, it may be true and false. It may be something similar to Big O or something. So the section 1's going to be similar but maybe a little different. Anyways, looking at the values, it says give the best answer. So there could be multiple answers, but there should always be a best one for each one. So we look at number 1, and we see that's a KV, and we should recognize that's some sort of hash or a map, either maybe a set or a heat or a hash map. So if we look over on the right, we see both hash map and set. So sets typically only contain keys. They don't really contain values, so we could probably rule out set. So I would say 1 is a hash map. 2 is a vertex, and that's part of a graph we just covered. And if we look over on the right-hand side, we don't see graph, but we do see edge, which is vertexes and edges make up graphs, so that seems to be the best match for that guy. O n log n is some sort of algorithm, probably, that runs in that time. So we know heap runs in log of n typically. Insertion sorts n squared, so that's not right. Hash map are usually O1. Radix sort is k of n. Edge and set don't really make sense here. Shortest path, that is not correct either. Binary search tree, that makes sense in log, or no, that doesn't make sense because all the operations there in the search tree are log of n. Finally, that leaves us quicksort, which is an n log n algorithm, so 3 matches with quicksort. Unique values, again, it's a value things, kind of like number 1 where we have the V. But unique values, remember, either a hash map can have unique keys, but a set needs to have unique values in its set. So I would say set's the correct answer for unique values. In our last class, we went over Dijkstra's algorithm, and Dijkstra's is the shortest path from a given location to any other location in that graph. So H is Dijkstra. Priority queue, and we typically make a priority queue from a heap. So heap and priority code match each other. Log of n, some sort of log n algorithm. Again, this is probably the best answer for binary search tree, as our heap is already taken up from our priority queue. A balanced means something that is even, and the AVL tree basically maintains its balance. So I would say AVL tree is number 8. N squared algorithm is basically one of our easier sorts, and insertion sort fits that algorithm complexity. And then finally, we covered radix sort, and that's an OK of n algorithm, which matches number 10 there.